Hi everyone, welcome back to the third part of these lessons on differential equations. Again, we have a first order differential equation, and this time it's not, dy dx is not given as a function of x or a function of y, but a function of both x and y. So now what will we do? Well, there's a couple of things we can do. Again, the first step is separation of variables. See if we can get everything with y and dy on to the left, everything with x and dx on to the right. So a little bit more preparation here before we get to the stage of an integral. I can see that we would have a common factor of y, and then there's 9x squared minus 1. That's nice. Now if I divide by y and multiply by dx, I've separated my variables. I should make a note, when I divide by something like this, when I divide by y, I must make sure that there's a stipulation in place from here on, y cannot equal 0, for obvious reasons. So let's take our integral now on both sides. The integral of 1 over y is ln of y. The integral of 9x squared, we have 9, x becomes cubed, divide by 3, integral of 1 is x, and don't forget our constant of integration. Now, we were given an initial value over here that y equaled this. So let's keep going. I note here that, that divided by that would be 3x cubed. So writing this in exponential form, y would equal e to the power of 3x cubed minus x plus c. Now we saw this in the last one. This is better off as y naught e to the 3x cubed minus x, where y naught just represented the constant e to the c. If I substitute now, my initial value, y naught equaled 1, imagining that you had a 0 for x here and here, that's just e to the 0, so it's really just 1. Then my function becomes 1 multiplied by e to the 3x cubed minus x. Now there's really no point in having 1 multiplied by taking up space, so that is my specific solution to this differential equation. That's a nice little quick one. They do get much more complicated than this, but the general principle applies. Even if we have an equation that's a function of x's and y's, we have to do a little bit more effort perhaps before we can separate out the variables and take an integral of both sides. Again, if we are lucky enough to have the initial conditions, we can move from the general solution to a specific solution in this case. Thanks for watching.